for a panel on this very generic title called Spatial User Interaction. In the next hour, maybe a little bit shorter or so, we'll hopefully discuss. I really like the discussions actually in the last 2 days. Discuss a little bit more on what we think spatial user interaction could be, should be, will be in future. I have 4 panelists here, and yeah, I think they will introduce themselves in a second. We have Kai, Rob, Sri, and Wolfgang. Thanks for being here. So, what is spatial user interaction or spatial user interfaces? We had this nice keynote yesterday. There's this 3S plus 1 suggested by Rob. You all, hopefully you all heard about it. It's like supernatural, spatial, smart, and social. But who actually is SUI? So where are we? Who are we? Where do we want to be? Where are our roots? So as you all know, we're kind of tied to like SIGCHI and SIGCHI and co-located with different conferences at different locations. And yeah, what's next, or where are we going to be? I think we can use this panel also as a forum to discuss things like the future of the symposium itself. What are current trends in spatial user interfaces? These are only some examples from our group or what we are doing. So you can really think out of the box, and I think that's why we're here. I think it's a very good forum to really go beyond 2D, 3D, whatever interfaces. And for example, use a VR headset while climbing. Actually makes fun. A little bit creepy, but it's really fun. And yeah, what's the future of spatial user interfaces and interaction? Would it be that kind of what Hollywood envisions, or do we have other ideas or visions in mind? So here are some kind of basic questions that we can discuss, or that the panelists might address in their position talks. And yeah, I'll just directly hand over to them. We are just ordered by alphabetical order, and yeah, handing over.
So I'm Kyle. I'm the main program chair this year of the conference, so hopefully I know what SOUI is. So just some very brief stuff. So I'm primarily, I would say, a VR researcher. I also call myself an HCI researcher, and a lot of people know me for my work in virtual agents. I run a laboratory, a virtual experiences laboratory at the University of Georgia. I also recently took on a sort of a weird role, I think because of the emergence of big data, and I was the only person at my university that had any clue about big data, as the Georgia Informatics Institutes for Research and Education director. I wanted to talk a little bit about my own personal VR hype cycles to give you an idea of where I stand. I emerged in the VR scene with the Power Glove. This is, back in the 80s. I was really young, but I might have been one of the first people to buy one, or my parents bought one. I remember I found it in the closet, ruined Santa Claus for me. But anyway, then I definitely saw some VR demos at Disney, and so I'm like peeking and then just sort of forgetting about it. Who cares? And then I started grad school, and I'm no longer a VR researcher because this is in the 2000s when VR is kind of terrible, and everything was about large displays, and a lot of work in virtual agents that was really productive. And then the VR viewers sort of came out, and so we had things like the cardboard, and I started doing some work in this area and trying to make some portable VR systems and things like that. I got really, really excited about it. The DK1 came out, and this is actually sort of a small decline for me, and just seeing that, okay, we're not going to get, the sort of grander vision of VR for a while. And then I had my first 5 demo, and just it totally changed my mindset. The tracking problem in VR was completely solved. And we could move on and actually try to build real applications. And now we're starting to see amazing video games in VR. If you haven't played some of these games, we'll see a talk by Alex Schwartz later, about Job Simulator. But there are so many really, really good VR games now. And I think it really highlights that things are changing, and we're going to have productive applications of VR quite soon. Current interests that I have, so I don't think we can really innovate as much in the games space anymore. I don't think you're going to see that coming out of academia, but we can certainly see what the challenges are. We can observe what's happening in the field and try to study them in more depth than the gaming industry is willing to study them, or at least systematically. But I'm also interested in non-conventional VR applications, and so I think we can make really good strides in this area and try to identify what is possible beyond gaming, because that's certainly where the market interest is right now. I'm of course interested in this idea of immersive visual analytics. You may have seen the poster upstairs by one of my students. I think this is a really powerful application because we're starting to deal with a lot more data. A lot more data means quite a lot more visualizations and potentially some more relevance of distributing these visualizations around us, making use of more of the space than we have available. There's a lot of good research showing large displays help with visual analytics, so it kind of makes sense that putting things around you might help. But also I'm very interested in the pedagogical approaches, the utility of virtual reality to teach things to people. And then I'm still interested in virtual agents with or without VR. I'm doing a lot of work still in that area. So what is SOUI? So it's of course this conference, which is some intersection of VR and HCI. A lot of great research here, but I don't think the conference is specifically focused on SOUI exactly, right? So we accept work that's sort of tangentially related. There's this idea of a spatial user interface. This is really spatial and 3D in this, when you're talking about user interface, essentially the same thing in my head. And it's basically just these controls, they're physical or virtual, they're arranged around you in some sort of, either their controls themselves are non-planar, or they're arranged in a non-planar way around you, remember, virtual or physical. But then you have this idea of spatial user interaction, and I think that's where this conference is at least the mean level of research, where you're observing people interacting with these and trying to understand how they interact more effectively, or just trying to better understand why they are interacting that way. And so I think of spatial user interaction as just a high degree of motion control, a high degree of motion involved, and essentially freedom from the confines of the display system. So, that's it.
Hey, that's me. Let me just see what my next slide is. Okay, good. So I'm Rob Lindeman. I'm from the Human Interface Technology Lab in New Zealand. You didn't put any dates on your curve, so I've been doing VR research since 1993, and I tell many people that, and they're like, but it wasn't around then. How could you? It's new. So this is at least the third wave of VR that I've seen kind of come and go. I played Doom on a head-tracked, head-mounted display in 1996. So it was patched heavily, but I could sit there and I could look left and right and I could shoot rectilinear things coming at me, moving through the space and everything. And this was on a Cybermax head-mounted display with unbelievable field of view. Unbelievably bad, but still unbelievable. But what I realized is after 5 or 6 hours, I hadn't blinked the whole time. So I had tears rushing down my face because I was so engaged in this experience. And so, while I was doing that, I said, it's very clear to me that this is, there's something here that we need to look at really carefully. And here we are like 21 years later, and you can do a lot of this stuff again, which is great. But it used to be that these headsets would come out and the 200 research labs in the world would buy them, and then they wouldn't sell any more units. Company would go out of business, and 4 years later, another headset would come out with the same cost, and all of us would upgrade all of our equipment, all of us meaning 200 of us. And then that company would go out of business, and you'd see this cycle, and VR is going to change everything. It's going to change the way we talk, the way we communicate, the way we have sex, the way we shop, the way we learn, and then nothing happens. Right, so Second Life comes out, Second Life's going to change everything, it's going to be great, it's going to be the 3D web, and everybody's going to, and then everybody jumped on and built their stuff, and nobody came except for flying penises, so that I think the key thing there is there has to be some reason to put on all this stuff. There has to be a reason to go to a special room or to put on this types of equipment, to invest in the equipment. And you can't just build it and they will come. There has to be a compelling reason for someone to put on all this stuff that they couldn't do in a more efficient, less cumbersome way, right? So if somebody's really good at using a tool on a desktop, after the wow factor wears off and they're standing there alone in their virtual world, they'll be like, now what? And so unless there's a way for them to see or do or go someplace that is worth the cost of, not just the monetary cost, but worth the cost and effort, then they're not going to go. Okay? So that's the main thing that we're looking at is how do we get to a place where it really is, there's things that I can do that allow me, that I can do in VR that will really allow me to see things in a different way or give me some insight. So a couple kind of takeaways. The first thing is that people are really lazy, right? So if you come up with a way to do something, we saw it in the keynote with Wii Sports, where everybody loves to play tennis, but then after a week, they're not playing it like that anymore because they don't have to. So you really need to design things that are balanced in terms of what you're having someone do and the benefit from it. So the main research areas that we're focusing on, I'm going to depart from this a bit, but anyway, the main research areas that we're focusing on is multisensory support. So giving somebody a fully holistic multisensory experience, combining visuals and audio, which are done. Like you said, tracking is done. I think visuals and audio are actually done, and I'm a computer graphics PhD. But in terms of most applications that you're going to come up with, the game engines today are doing a really good job on a lot of stuff. So what's left? So to get to 11, you need to add other stuff. So wearable haptics, floor vibration, wind feedback, water feedback in certain situations, smell and taste. So we're really, in the lab, we're working on putting all of these things together in a holistic way. The other thing is low fatiguing and low cumber interfaces, so you can spend 6 hours in and not get tired, but still be expressive enough to do what you need to do. So anyway, I'm going to stop because I'm an academic and we can go on and on. But again, so the main thing is to provide a holistic experience, provide what we call comfortable VR, where it's non-fatiguing and non-cyber sickness inducing. And then the third thing is we really are an applied laboratory. So we are a technology pull approach where we look at the user, the task they're trying to do, and the environment that they're in, and then we apply the appropriate technologies as opposed to solving problems with VR. We look at the problem and then apply the appropriate technology. And I think it's incumbent on all of us to think that way as opposed to saying, I have my VR hammer, where's the VR nail that I have to hit?
Okay. All right, so I'm delighted to be here to participate in this panel and to share my vision and ideas around what is HCI/spatial user interfaces. So I'm Subramanian. I work at the University of Sussex here in Brighton. My research lab is called the Interact Lab, and our lab is primarily focused on creating new display and haptic experiences. We primarily focus on manipulating wave fronts for creating these types of displays. So let me explain a little bit what I mean by manipulating wave fronts. So my background is in, it started in physics. I moved to signal processing, and then I did a PhD in industrial design, so it's a mishmash of many different things. And I try to bring as much of that as I can to the research that we do. And what we're trying to do is to create display devices or systems where we can on-demand summon this system and on-demand dismiss this system, right? So I'm in this room here, I'm talking to all of you, and I would love to be able to just wave my hand. Maybe a display comes here, I want to do something with it, talk to you about with that display. Maybe this sounds a little bit like Tony Stark, but hey, why not? We can do that. Yeah. So, but there's one thing that I think is slightly different from our vision. From who's the director of Iron Man? Anyway, who the director of Iron Man is, which is we want to be. We talk about mid-air systems, not just mid-air displays, right? So, so we want to be able to, as Rob was saying, see, feel, taste, smell, hear, everything in midair. So this is a small collection of some of the projects that we work on in my lab. You may recognize the face in the top left corner. So what Ben Stiller is holding there is our levitator. So what we can do there is we can float objects in midair using acoustic levitation. And what we are trying to do there is to be able to create displays by assembling small particles, by pulling them up. So, excuse me, I accept our displays are rather small sometimes. So the Tony Stark vision of a big, massive display is still far away. Nevertheless, it's a first and important step for us to be able to make small displays, okay? The picture further down to the right is the same levitation system, but what you're seeing there is a very small piece of meat with 2 lettuces and a small piece of bread being levitated. Yeah, I guess if any of you want to put a label on this, you would call it a burger. So that's what we're trying to do. So we will be presenting this as a demo later this evening, so please come and try it. I don't know if we have ethics approval to let you taste anything, but you can see the levitation happening with food items. So theoretically, it could be possible to have mid-air taste delivery devices of some type. And finally, what we have in the bottom is a bellow chamber through which we can blow soap bubbles. Who doesn't like to play with soap bubbles? So what we have is a fog or smoke-filled soap bubbles that we can release from this chamber. We can track the soap bubble and project onto it. And what that means is that we can put small ambient notifications on this mid-air display. But since we fill it with smoke, we can fill it with any smell we want. So when you pop the bubble, you get the smell, right? So you could have the scenario where you have an ambient notification system in your room. You're away from the room, you come back, and from the smell, the dominant smell of the room, you know who sent you most emails, right? Or who the notification is from. If it is your mother, maybe you don't want to answer it, or whatever, right? So this is a sample of what I feel is the direction which my lab is pursuing spatial user interactions. I'm always asked, what is the challenge in terms of pursuing this research agenda? Besides the obvious of funding, the other challenge we have is we are trying to bridge basic science with a vision of the future, and everything that we do is a small sample in between, right? So we are enabling a very small piece of this big jigsaw puzzle, and it's always important for us to be able to help other people understand how this piece fits the bigger picture. So what from science are we taking? What is it that we are contributing that is in addition to what people in material science or in physics already know? And what is the novel contribution of ours there? But also how this helps realize a vision of the future that perhaps none of those people in the other disciplines care about or even realized as possible. I think this is an important part, or it's an important thing that I think sometimes we forget as a community, which is how do we help others realize what is the big picture and help them connect the dots so that we can go from where we are here and now to that beautiful, better place we could be by doing whatever it is that we're doing as a research. I think in a large way, we are now talking about VR is almost here. Maybe it's still another hype cycle, we don't know. Or mixed reality, things are happening. Our own lab's vision is ever so slightly different from all of these visions, but whatever that vision may be, I think the best is yet to come. And what we have here and now is not the best. It's going to be there, it's going to come, and we want to get people excited about it and be prepared for this future, which is going to be amazing, whatever it is, but it's our job, I think, and that's the biggest challenge I feel as a community, to be able to help people understand what the future is, or how most of us are funded by taxpayers, how the taxpayers' money is helping that person who's funding us understand why what we're doing is important for them. And this is an important challenge we should not forget as a community. One last point that Florian asked me to talk about, or asked us to talk about, was, I forgot, what was the fourth one? You had a third point. What are the killer apps, for SUI? You get asked a lot, right? I mean, like you see the levitator and ask me what is the killer app for it. I don't know. I'm an engineer. I'm a scientist. I am an enabler. I am not a designer. To design apps, I know I have a PhD in industrial design, but I've kind of left that behind me. But I think it's not for me to explain what is that killer app, and I think you will find in the history many times that what people imagined as a killer app never turned out to be the killer app, to something else, right? So what is more important is to give the tools out there, let people do many things, play with it, and through that process of engaging with the technology, interesting applications will emerge, and that's what will help grow the community or help realize the vision that we want to have. So it's not going to be searching for this holy grail, right? I mean, it doesn't exist. It comes about through the process of searching for it. Nobody can tell us what it is. Anyway, that's my thoughts. So.
Okay, so my name is Wolfgang Stößlinger. I'm from Simon Fraser University in Canada, in Vancouver. And riffing off what Rob was saying earlier is that I've been looking deeply into what makes good, effective spatial user interfaces, and what makes user interaction, especially in spatial scenarios, very effective. So one of the observations that I want to offer is that, on average, looking across many different things, people are quite aware of the trade-offs that they face in terms of speed and accuracy and fatigue. And so while you may say, well, the Vive controller is a great input device, give a Vive controller to somebody, put it on the table, and slide it around like a mouse, and give them that as instead of a mouse, and everybody will run screaming from you, right? And that's a very natural reaction to it. But it also shows you the differences in input devices, right? And people are really good at recognizing that, 5 minutes, they may have the wow factor for the first 5 minutes, for the first 30 minutes, right? And then they kind of come to the senses and say, no, this is not a good input device, right? So there is actually, beyond the work, for example, that Rob Tedder and me and others have been doing in quantifying input device performance, there's today even more help available in terms of exploring these trade-offs. I want to just highlight one recent piece of work in this area that I did with some people at Purdue. That's on fatigue modeling. That's to basically quantify how strong the gorilla arm syndrome is. How long can you use an interface before it becomes fatiguing, right? Especially when you design things that happen in mid-air all the time. One of the things that I've been comparing the spatial user interaction work with is, of course, 2D user interfaces. And the reason why I do this is not because I believe that 2D user interfaces are better. I just see people comparing them with 2D user interfaces, right? I mean, what is the most common user interface for a computer game today? Mouse and keyboard, right? And why? Because gamers can express their actions the most efficient this way, right? And gamers are very, very, very sensitive on speed accuracy trade-off. They will expend lots of money to reduce latency, to get more precision from the mouse, and so on, because they feel and can feel it, that their performance is better. So along this line of thought, I've tried to characterize input devices, and together with Rob, or we, for example, recently looked at how well does, say, a leap motion work for pointing, and we tried it with the finger, and that didn't work so well. That's about 3 bits per second, so that's 75% of the mouse as an order of magnitude. The only input device that I've found so far that comes close to a mouse in terms of pointing is a chopstick. And one of the insights from this work is it's the precision grip that matters. It's not the whole hand grip, it's a precision grip with 3 fingers. And that affords a lot more precision and accuracy relative to many other devices. So Michelle Brown did this work. Interestingly, in separate work with Vanessa Wiebert and Jeremy Cooperstock, we found that a chopstick-like device that also tracks rotations is a really good input device for 3D docking. So this is not just a 2D pointing device. This is also something like a wand can serve quite well for 3D docking. And you may also say, well, we want 3D input devices. This is a technique known as shift sliding and was presented last year here. This is basically drag and drop with a mouse or any other 2D input device. So you can use this with raycasting, you can use this with touch screens. That affords the precision of mouse-based manipulation, but still gives you the ability to position an object relative to other objects anywhere in a 3D environment, including in positions where you can push it into the floor and so on. So this is, again, this trade-off. Here you have the precision of a mouse-based system, but the expressivity of a 3D system, right? And so now, of course, this is much better than many CAD systems, and we did compare this with the traditional CAD interface, and this, of course, works better. And then you can go crazy and actually slide objects on point clouds and stuff like this. This is just the extra stuff. But this is, again, an interface that tries to merge that efficiency with the expressivity. And I'll just keep the video running here, but stop here.
Jump over. So thank you for the very inspiring position talks. I will now hand over to the audience. Maybe you can start with the first round of questions. Maybe you can also address directly one speaker, and so we can dive into a lively discussion, hopefully.
I want to say about the multidisciplinary aspect of this interesting session. I'm a mechanical engineer and I use a daily CAD system, 3D modeling CAD system. I think in the next year we will have a revolution in our systems. Actually, CAD vendors are pretty conservative in keeping their old interfaces, but probably other partners probably will change. So I am expecting the revolution not from the CAD vendors. Actually, they are doing like car makers. They are doing the same car, changing just stupid things. Instead, somebody is doing really the real electric car and is changing the market. So. I think we are promoting. I'm doing this research So I'm here from mechanical engineer because I really believe, since my PhD, that this is the way to go. Actually, there are no CAD system, really CAD system, which can be called CAD system, and you can really model something that you can produce for really industrial applications. So this is why I throw the stone, not in a bad way, to say that there is some standards we are looking for some really effective interfaces which can combine in 3D precision, but as well without losing the natural feeling, and also they can really work in working conditions. So I mean, just a chair, just simple models are okay, but you have to see how complex can be really not a car or heavy machinery or plant. So the CAD models become pretty complex and tight with a lot of components, and so let's say we have to stay on the same table and interact really, because the model may be a little bit more complex than just a couple of what I've seen till now. So thank you very much.
Anyone likes to comment?
So welcome. So it's really great. I think application, as Sri was saying, it's the application areas that are going to drive things. So we can't dictate what the killer app is going to be. It's stuff that, I really look at, our lab in particular is, we have 2 out of the 3 things you need to do real work is we really understand the technology, we really understand the evaluation, but we are not domain experts in whatever we're supposed to be helping with. So we really try and work with the domain and pick their brains about what their current process is, what they're actually trying to do, explain what the limitations are of the technologies and things, and then try and solve the problems. There has been a lot of work on assembly tasks in mechanical engineering, on CAD systems in mechanical engineering for the last 20 years. And I know the technology is better now and everything's really different, but it's not. I mean, it is, but it's not. So there are some things that the idea of doing something in VR to do it in VR has been beaten a lot. What we have found trying to do world building in VR, for example, is that manipulating vertices precisely is not something you want to do in VR. Your arms are going to fall off, first of all. Second of all, your arms are going to be shaking so much you're not going to be happy. You can do snap grids and you can do other types of things that will help. You're just not going to want to do it after you realize, wow, I'm so much more efficient on the desktop for doing this thing. Things like understanding spatial relationships are good in VR. The size of something, the distance that something's away, these types of things that, wow, I realize now that by standing here and this time of day looking out that window, that building is totally going to block all of the whatever it is that I'm trying to, right? So the idea is that there are just some things where you're going to be really, really efficient to do this particular task outside of VR. And so don't throw that away because it's old. And, move the stuff into VR where it really makes sense and leave the stuff that you're really efficient at using the older tools. And that's the only advice that I would give is you have to match the task with the interface. And you'll just not be happy.
I'd like to add to that, because I agree wholeheartedly, about not wanting to precisely manipulate vertices and things like that. But I'd like to add that it's not an either or. You can pop up a window in there, and there could be a mouse sitting on a desk near you, and you can go and do that and have both of them in the same space. And that's really where I see things going, is that we're going to start having a lot of input devices around us that are pre-built for the task. And yeah, we'll have the ability to grab it, if we're over there already, to grab the vertex and move it. But we could always go back over to the mouse and use that too. So that's really where I see things are going.
An observation that I want to add in that context, and so what Kyle just said is actually not that unrealistic. If you look at how people are using head-mount displays today, a lot of people are sitting. A lot of people are sitting, especially if they're using the head-mount display for longer times. So having a mouse there is not out of the question. Exactly that, right? So one of the reasons, I mean, one of the things that has motivated me to design techniques like my lab to design techniques like that, because what matters is that you have an input device that can give you 2D plus input, not necessarily 3D input, but 2D plus, and that can be a touchscreen in augmented reality. That can be ray casting, right? That can be a mouse. It doesn't really matter per se. All you need, you know, once you have reduced the cognitive complexity from a 3D problem to a 2+D problem, it becomes easier. So you can go forward with that.
Yeah, thanks a lot. Fascinating introduction from you all up there. I was just wondering if anybody had an opinion about file storage, and somebody's laughing. Because so the problem is that we're using these antiquated, parent-child relationships. Hierarchical file storage has nothing to do with the way that we spatially remember things, right? So spatial cognition, and which is more around emotion and social kind of, context and temporal. So temporality is not hierarchical the way our desktop. But we all use these systems. We become hypnotized by them. I don't see anybody talking about this like they used to 10, 20, 30 years, maybe 20 years ago, 30 years ago. And I don't see the major manufacturers, Microsoft, Apple, Google, or anybody. Google bought a company called BumpTop, which was like you could turn your desktop into 3D, and that was really cool. But it seems to me that the practical, I don't know about you, but my computers are a mess. I have files buried everywhere, and you can't find them. And so I am really, I would really love to design. I'm a designer, so I would really love to design that system. But do you know of any work that's going on, or do you see that as a potential use case, as a around the killer app, or is there any work going on in that area? Thanks.
I'll take this on, but please add in here. So I'm a co-author on a book on immersive analytics, and which has to do with big data. And the same kind of question arose exactly there, and we had a long debate around this. And there is two. So I have a couple of observations that will help here. One of them is there's two kinds of data that are relevant for the question that you're asking. Namely, there's spatial data and there's abstract data. And I kind of chuckle every time I see a 3D visualization of Twitter sentiment. So why is arousal going in this dimension while love and hate is going this dimension, or something like that? There is no real good dimensions there. So file storage has that problem. Why is the budget up and the reports down? You have no good answer to that question, right? There's no spatiality to the information. And so in information visualization and immersive analytics and so on, the general consensus is 3D is useless for this kind of stuff because people don't have a good spatial mental model for this. Okay? So now, of course, many companies have tried spatial file storage. None have really succeeded. Right? And I expect that for this reason to stay the same, because there's no spatial mapping that makes sense.
I agree with what you just said, but
Yes, go for it.
I think that that only applies to static visualizations, not ones you can move. And so we, as human beings, we encode things spatially. I put this over here, and I can look away from it and still know that it's over there. And so I think the ability to move things around in space and then recall them by going back to that with your body actually is a powerful metaphor. But it's not, I agree, there's no reason for certain things to be up or down.
Yeah, just search. Just type in what you want to say, and let the system find it for you. Don't worry about it.
Google it.
The problem with that, and that was a really cheap answer, by the way. The problem, search sucks though. It sucks on the Mac, it sucks. And the problem with search is you need to know what you're searching for. I have many files, and many of them now sit on hard drives. I don't know how to access stuff that I think I know I have.
But it's not files you're looking for, right? It's content you're looking for.
Yeah, but they're represented as files.
Yeah,
so
but you've now introduced one level of abstraction. Why is it a file? You really want the information that's in the file. Where the file is actually shouldn't matter?
The type of the file might matter anyway.
Right.
You know, because the content might be visual or it might be textual, you know, but
that you can search for very easily. Audio files.
I think though, like I'm very much interested in the butt, you know, in the spatial. I'm very much interested in. We do because I'm a cognitive scientist, so I know. So I totally, you know, there's a ton of research that shows that yes, spatial memory works, and in training tasks we can see that spatial recall. We saw yesterday in one of the presentations that recall tasks are increased.
Not at scale. So we both said the same thing. Not at scale, it doesn't work.
Not at scale. That's what the.
If you have so much information, at some point you're making stuff up about where it is. Oh, it's here versus here versus here. Because I just have so much stuff, or it's here versus here versus here.
Right. Gotcha.
I just think it's fine for not a lot of data, and I think that's probably in the book.
Okay, so that's the gotcha.
I agree with you. I have stuff all over the place, but search is the best you got.
Okay.
I would argue that VR is really flexible, and so yeah, you can have search, yeah, you can move things around in space, yeah, you can have 3D visualizations that are sitting there you can look at and bring closer and zoom, or you can package them up as a little file. It's just flexible, just like having your 2D interface that you can throw up there and use with a mouse. And so that's what I'm really excited about, is that we no longer have to choose. I'm not constrained to the 24-inch monitor in front of me. We're getting there.
But, sorry, I had to do this now. I agree that you can do lots of things by organizing things spatially. One of the costs that you incur, and that's the thing that sobered me up at that point, was the cost of navigation is not zero. Moving around costs time, regardless of which method you use, even if it's just teleportation, which, yeah, great, but it still costs time. So if you can't see it, it's harder to navigate to it. You have to search for it, right? And that if you can't see it because it's too small, same problem, right? It doesn't have to be occluded. It can just be too small, right? If you have 15 levels of hierarchy in your files, you can't see it.
I know in that corner I have like this type of, and over in that corner, so maybe it's more fun to move through a space. It does have something. I don't know.
So this is my 2 cents on this. I remember quite a few years ago there was a study, I think Steve Whitaker did this study on how people choose to keep paper or discard paper. When he and his team moved from one location of the AT&T lab to another location, and he found that junior people stack stashes of paper, and senior people are very good at knowing when to throw it away. So, so maybe it stays.
So first of all, I like that last comment, because now I realize that I'm still a junior person because I don't throw anything away. Since maybe a follow-up question, since we currently talk about big data, and first of all, I really agree with everything you said, and even with all the buts that you say. So since big data, so maybe we can talk a little bit about the third S that you showed, the smart part, and nowadays, or with maybe the last 2 years or so, machine learning has been used and thrown basically on every problem involving big data. And we have really good results regarding object recognition, speech recognition, all these kind of things. I'm really wondering where our community and spatial user interaction could benefit from these machine learning algorithms. So I see some application in gesture recognition and speech recognition, etc., but I'm wondering what your perspectives are. Where can we use artificial intelligence to make our interfaces smarter or more intelligent?
So I've been thinking about this a lot in one of my new role that I've taken on, and the best I can gather is that we are not big data researchers. At least most of us aren't. We're not machine learning researchers. We're not the domain experts, and so I think we're going to have a really hard time using these effectively to make our interfaces better. But I think where we can actually add to the discussion is allowing people to better work with machine learning systems, to better work with agents. That's sort of where my mind is around this problem right now, is that these systems are going to be taking over more and more and more of our lives. They're going to be driving our cars, right? They're going to be automating a lot of the tasks at our workplace. How do we sort of stay in the loop or on the loop? And I think VR has a role to play there in better understanding, especially when those things are manipulating physical, spatial stuff.
So I think it's a great question, and I haven't really thought about it much. But what I would say is, if I think about other things that I interact with, I think any sort of predictive systems, or so if I'm moving and the system sees that I'm about to select something over there, it might use some machine learning to figure out what my intent is. And this has been done in 2D for a long time in terms of predicting which target I'm trying to hit and fits tasks and things like that. So I think that there is good stuff for us to tap into in terms of predictive and completion things. For travel techniques, same thing with Google. If I start typing something into Google to tell me, it tells me in some semi-intelligent fashion, tap here because I think you're going to want to go home at this point, or tap here because you just went to that place at this time yesterday, or something like that. So I think, and these are very, very low-hanging fruit, right? But I think that these things could be used a lot to remember how I manipulated that object or where I put this thing, and then when I manipulate another similar thing, it might say, oh, do you want to do this the way that you did that one, or something like that. But again, I think it's true. I think we really need to work with experts.
I mean, a spatial Google would be cool. It needs a lot of data. One of the things that really makes Google, I mean, people have tried to replicate what Google can do on smaller scales. It doesn't work on smaller scales. It needs a lot of data, right? It's one of the limitations of the Google approach. So Google on your personal scale is a very different thing than Google at the scale of Google, okay? And it's just, you would wish that it would work differently, but I don't think it's easily possible at this point, right? But you know, a spatial Google that, you know, you have your spatial memory relative to what you're doing is great, but then you realize you're running out of space, right?
Spoogle.
Spoogle. Spoogle. Spoogle.
I just want to add regarding the lot of data that we need. Currently, we have millions of head-mounted display users who interact in some way in the space and produce a lot of data. So the data will be there very, very soon. And then I think it's a matter of question, what can we do with this data to make the interfaces better?
I really agree with that, it's a gold mine. VR is a gold mine of data about people. Just very much like we have a really good data about mouse clicks right now. And potentially we're going to now have eye gaze and social interaction. You know, it's Second Life, but on steroids in terms of, the behavioral scientists must just be, they must be giddy, salivating over the potential that's out there right now. There's certainly privacy laws to consider there. But in the States where we have none, it's not going to be so, they're giddy. They're really, really happy.
The camera's on.
Yeah.
Oh, sorry.
Careful, you might not be able to fly back.
I know, right? They're not allowing me in.
So I've heard lots of people in machine learning and big data say data is the new oil, but the way we used oil is not the proudest moment of humanity.
Yeah.
So we should be careful what we do with it.
So I wanted to add up to the comment of machine learning, and just one quick, well, he left already, but there are no hierarchical data, and I do think that content is important. So yeah, in terms of machine learning and all this big data out there, it's kind of hard to think about how, for example, you could visualize this on 3D, and I agree that 3D visualization is complicated. I've been trying to see if I can bring like 2D building block programming to 3D in VR or just on the desktop, and just that is complicated when you ask students how does a function looks, how does a loop look. In most of the cases, their drawing goes back to 2D, right? Like this is a loop. So in terms of machine learning and in particular in gesture recognition, I think one of the important things to realize, and at least it has been for me, is that not everything works in interactive systems, right? I see sometimes gesture recognitions that are great, but they're offline. So you don't know if it's going to work. I mean, you don't know if it's going to be able to respond in a small 10 to 20 millisecond window because you're sharing everything else, so you can maybe hit a 60 millisecond, or even less threshold, because otherwise the user will become frustrated that the gesture is not being recognized. But there is, I think, a lot of stuff in terms of machine learning that can be done. I've been thinking a lot about gesture prediction, right? How can we determine what kind of gesture is going? So I think there's a lot of work there that I think the field can look at. So I think there are opportunities in machine learning, but sometimes I have students that watch the Coursera course in machine learning, and they say, oh, let's do this for gesture recognition, but I say, that's not gonna, it will work nice offline, but it's not gonna work. So anyways, I just have some random thoughts. I'm still jet lag, so thank you.
So maybe you can kind of start wrapping up. Maybe one last question, and then we'll wrap up some final statements.
Yes, I was thinking just if how much voice control can be important in VR environments or augmented reality environments. I think that I would like to say in a CAD model or in a model to bring the chair near the other one. So probably these interfaces will be kind of undervalued somehow, but I'm start using the dictate papers using voice recognition. It works for Italian, so it worked in the past only for English. Now it works for Italian pretty well. So I wanted to ask you if you believe in such approach in the future, combined with intelligence, for example.
Actually, I think it's okay. Maybe my answer is very naive, but my sense is that a lot of these things can be done here now, today. All the tools exist. All the, as you say, voice recognition works really well. Plugins exist for various CAD programs where you can create such command interfaces. A lot of times it's not there, perhaps because they call this valley of death, where somebody has to jump from a research idea to a commercially viable product that will make money of some shape or form. And people miss that bridge between the those two things. And the kind of examples you're highlighting right now are not there because we missed that bridge. That's my take on the situation.
So speech interfaces are really, really troubling. Why do we have speech in the first place? We have it to communicate with other people. We don't have speech to communicate with computers. That was never, we didn't evolve that, ability. So I don't see speech ever really taking off as a computer interface because of that, unless we're talking to robots that look like people, and then it makes sense to us, I think. But for anything you want to automate with a command, you can also put a button out there and do that as well. And I think that it's just it's not going to ever map well just because it was not built for that.
I totally disagree.
Awesome.
So I think commands are a really good place for this. So a lot of, I'll be a little bit controversial. I think gesture systems are really way overhyped. So I think there are probably 5 gestures that are intuitive, and everything else you're making up. So I can grab something, I can move something, I can orient something, not precisely, and I can rotate it, I can let it go. That's really it. I mean, anything else I'm making up. I can pinch zoom, I can rotate. So I've got these, but there's a very small set. So I'm very limited in gesture systems because I just think that it just takes a long time to invent and then learn and then execute gestures that are distinguishable enough from other gestures that they're going to be recognized at a high enough percentage that I'm actually going to want to use it. So actually, what?
You're not able to speak without gesturing.
Yeah, then that's fine. But these gestures, you understand my gestures, right? So, and I'm not even Italian. So maybe gestures for Italians are very important. But I will say things like, loading a file, like Cortana, please load the file that I stored yesterday that I was working on. There's no reason I should have to do any sort of spatial user interface to do that, right? That should just be a no-brainer or someone else's brainer. I should just be able to say it, and everything that I've said should be able to be recognized, the temporal aspects, the numerical aspects, everything. Who called me 10 minutes ago? All that stuff. So anything that I'm doing in my space related to CAD, there are a lot of systems around the big 5 tasks that Bowman and everybody have defined, but nobody is working on system control stuff. Why? Well, you really should just use voice to do a lot of the system control stuff, I think. But I'm being.
Go ahead. No. So your example, you're talking to an agent. I mean, again, if the thing you're trying to talk to is intended to be a person, right? It's your personal secretary or whatever, then voice makes sense.
So the file dialogue, the load dialogue.
You just said Cortana, right? I mean.
Well, I did that purposely, but if it's file, open, recent, and this thing, that's not an agent per se.
Agent that is part of the CAD system.
I agree. And so if it's something another human being could do for you, then I suppose it makes sense. But.
The natural language and the community is, of course, here one of the bottlenecks, because the context that you need to understand, please call the person that called me yesterday during lunch, is not that easy to understand.
It works.
It works. Some of that works today, but describe with words that you want that chair over there.
So let me tell you, I'm sorry.
To be
Let
precisely.
me give you an example. So I did this a couple years ago. I said, I talked into Google. I said, who's the president of the United States of America? And it said Barack Obama. Then I said, what's his wife's name? It said Michelle Obama. I said, where did she go to school? And it gave me the right answer. Now, if you think about that string of things, there's a lot of stuff that's unknown by the 3rd question I asked.
There's one example I'll give you. Now, I suggest everybody try this, right? Try to set an alarm when the sun rises on your phone. They say Siri, what's the Android version of it? Okay, Google or Cortana, just try it. And I want to know how many of that works. In my phone, it never works. I've had people try it on Android, it doesn't work, even today.
I'll try it.
Just now.
So while Rob tries that.
Okay, Google.
Yeah, I want to add actual CAD system speech, or just a simple command speech. We should go over this. There is maybe some underrated stuff. And what I would like to add that sometimes when we have this working session with colleagues, one say to another in front of a CAD, bring the chair or bring the bolt there, make a hole here. So yeah, surely we are not used to talk with a blank screen, okay? But if we create an avatar, we create a virtual a virtual simulator of a colleague or something that helps you. But I find a very common situation when somebody is on the computer doing CAD system and somebody else says, okay, move this fridge 10 meters on the left, because we do also some modeling of interior design. And there is, the client say, I want red. I want my kitchen red, and somebody is doing the job of doing that. So why we don't bring this in virtual reality and with an assistant like that?
The reason, before Rob had his good point here, one of the issues is that spatial relationships and associated things are easy to express with words, but require a high degree of intelligence to understand. Move the bridge 10 meters to the left. Which left?
It's like Barack Obama. You are
Yeah. Now, the which left can refer to so many different things, right? It could be to the left of the bridge, but seen from which side of the bridge? It could be to the left, seen from the person who is speaking. It could be to the left of the person who is sitting in front of the monitor. Every one of those lefts is different. So which one do you pick now?
I think in particular the kitchen is just one direction usually. So I mean, there is I think technology is there or nearly there. So we as a researcher, we should start to forget about that now. Okay, Google, set me the alarm when the sun is okay, and it doesn't work, because I saw incredible improvement in the last year. So probably tomorrow it will understand move in that direction, north, south, east. It will do it for me. And then if we consider voice plus gestures plus, so you start to look the input at a different multimodal approach, I think that we can really forget screen and keyboard. We can trash them together with other old technologies, because surely most of people here, I think they believe in these headsets, which will replace even mobile phone, I think. So we'll not have a keyboard, we'll not a mouse anymore. So I want to keep the fire, the discussion with that.
I don't think we're going to have just generic speech interfaces, because I think we have that. We've solved general purpose AI, and that's bad for us. But I agree with you. So just conversion of speech to text is going to get quite a bit better. And that's useful, right? Because we don't have the ability to use keyboards when we're moving around in open space. Unless we have keyboard pants. Keyboard pants do exist, by the way. You can buy those. So anyway.
And on that note.
Yeah.
Good, so thanks everybody for this nice discussion. I really like to have a really short, like 30 seconds to 1 minute wrap up from everybody, if you like. And yeah.
You can go first.
Yeah. So I want to go first because I want Wolfgang to answer something. So a while back, actually, Wolfgang convinced me that you cannot design a better first-person shooter than with a mouse and a keyboard. And he convinced me. I said, yeah, you're absolutely right. I don't know what I would possibly do. But now, having played VR games, there are games that you can build in VR that there's no way you can build a better mouse or keyboard interface for. And so that's what I've really enjoyed seeing. Go play a game, Echo Arena. It's fantastic. There's no way you can build a mouse keyboard interface, and I love playing it. And I don't care that it's fatiguing or sickening.
Go for it.
I mean, if you want to answer?
Yeah.
No, you don't answer.
Great. Finally, somebody has risen to the challenge. Yeah. That's all I'll say.
I've kind of said everything, so I'm not going to take up any more time. But this is great, and again, talk to us afterwards or in the break or whatever. I stopped doing it because I don't like actually use technology.
Couldn't understand him with all the noise.
Yeah. Noise pollution, yeah. Yeah, I mean, I think Rob summarized everything. I have nothing additional to add. It was great to be here and share my thoughts with all of you. I'm looking forward to seeing all of you in the reception this evening.
And just to make the point on Kyle here, sometimes of course, we have preconceived notions based on previous research. The real points of learning happen when we actually realize that something that is a commonly held belief or clearly documented thing that is not true, okay? And so those are the real challenges, because that actually pushes the field forward.
Okay, so and with this we're closing the panel session. I'm really enjoyed it. Maybe we'll give a warm applause to all speakers. So be creative, build cool SUIs, think outside the box, go climbing in VR or running or snowboarding.